All right, so there's one more impossibility theorem that you might have heard before, that it's impossible to trisect an angle with only a compass and a straight edge. So you're going to prove that result for homework, but before we can do that, I need to set you up with a little bit of a discussion about angles, because we haven't talked about constructing angles at all. So it turns out that our idea of constructing real numbers, of constructing lengths, is all we really need to talk about in order to get our hands on angles very easily. So this theorem that we're about to prove says an angle theta is constructible if and only if the real number cosine theta is constructible. So in order to talk about whether we can construct an angle, all we need to do is talk about the cosine of that angle and whether we can construct that length. So for example, we know we can construct 90-degree angles. There were some pretty easy constructions to make perpendicular lines. We also can see that in terms of the cosine of 90 degrees being a constructible number. We know we can bisect angles, so that means we can make a 45-degree angle, and that's equivalent to saying we can construct the length cosine of 45. So in terms of other angles, we're going to try to think about the cosine of the angle and whether that's a constructible number or not. So here's how our proof goes here. So if we're going to do the forward direction of this if and only if, that means we're going to assume that theta is constructible. So this is an angle that somehow we can make using triangles or some other method. Okay. What this means is we can do the following construction. If I can make angle theta, whatever theta is, then I can make that construction, and then I can make one of the legs exactly length 1, okay, by just cutting it off at the appropriate place. And then that other leg that's at the bottom, the horizontal one in my picture, I can drop a perpendicular bisector through that point to that leg. So I can drop this perpendicular, I don't mean bisector, I can drop this perpendicular through that point. Okay. And then what I've set up is a little right triangle, right? And so this side length of that right triangle, using a little is just cosine of theta. And so I've figured out how to make length cosine of theta by drawing angle theta, making one leg, side 1, little right triangle, then gives me side cosine theta for the third leg. All right, the backwards direction is pretty similar. It's going to be pretty much the same triangle, but we need to think through the steps of our construction. So this time we're going to assume that cosine theta is constructible, that that's a length that we can make. Then we can construct the following picture. Okay, so this time we know we can make length cosine theta, so I'm going to start there. I'm going to make something whose length is cosine theta long. Through that point at the end, so imagine this line extends out. I've cut it off at length cosine theta. Through that point at the end, I'm going to make a perpendicular, which we know how to do. We can draw a perpendicular through the point on the line. And then I'm going to set my compass to be length 1. My compass at length 1, I'm going to put the center on that left-hand point of my segment, and I'm going to draw that circle. I'm going to try to draw a circle of radius 1 and see where it intersects. And it's going to intersect in 2 places like that. And by doing that now, using again a little bit of trig, you can figure out that that angle right there has to be theta. And so using a length cosine theta segment and a length 1 segment and a right triangle, we end up constructing the angle theta. All right, so what we're saying here is to talk about constructing angles, all we need to do is talk about constructing the length cosine theta. So now you're going to use that as well as the corollary to prove the theorem that's at the bottom here, that an arbitrary angle cannot be trisected using a straight edge and compass. And the proof that you're going to do is similar to the previous ones, where show it's impossible to do this with an arbitrary angle by saying we can't do it with this specific one, so we definitely can't do it with any one that we want. So the angle that we're going to use for our example, our proof is 60 degrees. So we'll prove a 60-degree angle can't be trisect. And so definitely we can't trisect any old angle, because here's one that we definitely can't do. Okay, so watch for that as one of your last homework assignments.